Alright, this is 3.1, derivatives of polynomials and exponential functions. So, a derivative. You want to know the derivative of a constant. Constant like c. The slope at, the derivative is just another word for the slope at this whatever value. Function, number, something like that. And so the derivative of constant function would be derivative dx3 would be like 0. It's always, anything, the derivative of any constant is going to be 0. And to show that is a graph. Let's just say the function is f of x, 3. Let's be 3. Let's just say 3, yeah. This is the graph, right? And the derivative of it, so basically at every single point here, what is the slope? That's the equation of f prime of x, derivative of x. This is a horizontal line. So at every single point, the slope is 0. That's why the derivative of any constant, 3, 4, -2, anything, is always going to be 0. Alright? Now, to find actual derivatives, the things that are not constant. Let's just say x of 7. How do you find the derivative of that? Well, we would use something called the power rule. So derivative of x of 7, right? The power rule states that derivative of any x to the nth. Using the power rule, this would be n times x to the n minus 1. That's the power rule. So an example of this would be, still using the x7th, derivative of x to the 7th would be 7x 7 minus 1, which would be 7x to the 6th. That's the power rule. Kind of simple. You just have to memorize that, bring down the n, and remember to do n minus 1. So something that goes along with it is the constant multiple rule. It just states that instead of x to the 7th, there would be like 7x to the 7th. And finding the derivative of this would be bring down the same thing, just because there's a constant here, it doesn't change anything. You still multiply it. X, 7 minus 1, 6. That's the constant multiple rule. Okay. There's also another rule, the sum of difference rules. Basically, derivative of, just say an example of 4x squared minus 2x. How do you solve that? Well, it just states that find the derivative of this, everything basically remains the same, so like 8x minus 2. See how this correlates with this and this correlates with that? Also, another thing about this, negative 2x, you might be wondering, how does that just become negative 2? Well, it's the power rule, but up here, there's a 1. So bring that down, same thing, negative 2, 1 minus 1, and x to the 0th equals 1. So that's times 1, so basically negative 2. And there we go. That's the sum of difference rule. Another rule is e to the x. How do you find the derivative of this? This equals the same thing, e to the x. And the derivative of this, same thing, e to the x. It's always going to be e to the x. Alright, that's the last rule I'm going to say. Now, why would we find the derivatives of these numbers? Well, let's just say you're given a function. Right? And you want to find all the horizontal tangents. Make sure that there's values, find the values where there's a horizontal tangent, where basically the slope is 0. Slope 0, right? So, to solve this, we'd find the equation for every single point on this f of x. The slope equation of every single point on this f of x. So you find the derivative of f of x. Do the power rule, 8x minus 3. And the derivative constant is 0, so there's nothing there. This is the derivative of x. Now, you want to set it where this is the slope equation, right? To find every point. And you want to find where the slope is 0. So you set it 8x minus 3 equals 0. Solve that. 8x equals 3. X equals 3 over 8. So you know at x equals 3 of 8, the slope is 0. Now you can go plug this back in f of x and find the y value. But I'm not going to do that. So now you know how to take the derivative of polynomials and exponential functions.